Well, thank you all for taking part of your Saturday afternoon to come listen to me. And listen, if I can get a group of people to listen to me talk, I'll go anywhere. I'm easy. My name is Paul McGowan, and I'm one of the founders of PS Audio. How many of you are familiar with PS Audio? Oh. Well, then I'll make the little history of a real quick one, just because I don't know how many of you actually know the real history of the two criminals that started it. The company was founded in 1974 by myself and my partner Stan, and so it's Paul and Stan. And we started out making little phono stages. We sold them for $59.95 each, and they came with a money-back guarantee.
Things have changed. Yeah,
well, and you know, I told the other group that this is a bit of a funny story. We probably sold 3,000, maybe 4,000. There were little boxes with a money-back guarantee. We probably had 10, 15 of them returned. But one that was always memorable, we got one back, and the guy was very upset. He felt that we had robbed his stereo system, and not only did he want his money back, he was angry. He wanted his money back, and he wanted the shipping, and we had never, most people just said, I don't think it's as good, because we had said, if you take this box and you connect it up to your phono or to your preamplifier or your receiver, and you play your turntable through it, it's going to sound better than what you have. And if you don't think so, bring it back. And one of the things we prided ourselves on was that it was really the audiophile's dream of making the speakers disappear. As you know, if you have a high-end system, one of the things you want to be able to do is turn the lights off and not be able to tell where the speakers are. I mean, I've worked for 40 years building equipment that does that. You know, that's always what I'm looking for. And this guy was really angry because we robbed his system of the ability to tell the left and right speakers from each other. He was angry as he could be. He said, I could turn the lights off and I could point, you know, left and right. And when I put this on, I couldn't tell where they were. So you robbed my system of the left and right. And we actually used that in an ad. And Mr. Ask Kansas, I think his name was. He was very upset. But anyway, so we've been making high-end equipment for a long time. In 1990, I sold the company. Stan left after about 10 years and started Superphone. I don't know if it ever made it over here. And I continued on with the company. And in 1990, I sold it, and I wanted to do something different. And Arnie Nudell, who was the founder of Infinity Loudspeakers, he and I got together and we formed a company called Genesis, which made loudspeakers, and big giant Gen 1s. They were like the Infinity IRSs. And we did pretty well for about 7 years, and then Arnie and I started, and so in 1997 we got a divorce, and I bought PS Audio back, which is actually interesting because the guys I sold it to, that was the era, if you remember, the Lambda and the reference link and the Ultralink. Any of you remember any of those products from PS Audio?
Yep.
And it was very successful. And then they had a partnership squabble, and it went. So in the end, I bought it back for $1. Yeah, which was kind of cool. And there's a long story behind it, but I won't bore you with it. But yeah, I bought it back for $1. And when I bought it back, I wanted to, as is the way I am, I wanted to build something that nobody else had. And everything PS Audio has always done pretty much been that way. We don't like making products just because somebody else makes one. We're going to make one too. Our products have to always have some reason to exist that are unique. And so, you know, when you leave a company and you come back, you have an opportunity to rethink everything. And during the first era of PS Audio, we got very big into power supplies. In fact, we figured out that the actual amplifier itself, or preamplifier, was almost less important. The design of it was almost less important than the power supply. That the power supply was one of the most critical factors in the design of any product. And we were one of the first guys to really discover this. We made big transformers and big power supplies. And we actually discovered this. My partner Stan discovered it. I remember one day he called me into the listening room and he said, "You got to hear this." We had a pair of Magnapans, MG2s. So we had a pair of MG2s in this is a long time ago. He said, "Sit down." Okay. He said, "Now I'm going to," and I was used to this because one of us would come up with a circuit change and we'd listen to it. Yeah. So he played something. This is, of course, back in the day of the records, the CDs. And then he said, "Okay, now I'm going to change something, and tell me what you think." And he changed something and put it back on, and my jaw dropped. Whoa! Do that again. That was stunning. And I thought he had made a change in the circuit. Turns out, what he had done was simply replace the transformer on the preamp. And he had done this originally by accident because he was ratting around and couldn't find the proper transformer. And all our transformers used the same voltage, but he picked out one from a power amp, but it happened to have the same voltage. So this was just a big transformer. This was a little weenie transformer. Now, preamps don't need current. They don't need a lot of current. So it made no sense to put a giant transformer onto a little preamplifier. And so many of the things that happen they happen by accident, just because he didn't have one. We tried it, and the sound difference was just stunning. And it, for years, made no sense to us whatsoever. The thing wasn't consuming more current. We later found out it was the DCR, the resistance or the impedance at the output of the transformer was so much lower because the wire is so much thicker, and there's fewer turns and all this other good stuff. Well, what that taught us is the value of power supplies. Power supplies make all the difference in the world, and in all of our products we use, still to this day, big transformers, high voltage. We do a lot of that stuff. We've always done that. All of that based on that experience. So in '97, with that in mind, when I started the company back, I figured, there's plenty of great amps, plenty of great preamps out, but no one's really starting from the wall socket and building a good foundation and bringing it out. There were a couple of power conditioners out in the market at the time, the MIT Z stabilizer. A couple of guys had some goofy power conditioners, but no one really had anything that was interesting. And every power conditioner I ever hooked up, it at first sounded cleaner, and then all of a sudden it sounded sterile and robbed the music of the life of like upper tones in a piano or in a guitar were missing. They were gone. I sterilized it. And so inevitably I go back, and I thought, that doesn't make any sense, because I know if we give it better power, it's going to sound better if we do it right. And so it occurred to me that a power conditioner is nothing more than just a filter. And actually what you're doing is you're putting something in series with the power line. And that can't be good, because any kind of thing you put in, whether it's a power cable or whatever, if you put something in series, it's going to make it worse. So is there a way that I could make a product that would make it better? And then it occurred to me, yes. Actually, if I could get rid of the power company and put a little generator in my home and make my own electricity, then I wouldn't have to have the neighbors sucking down my power and putting stuff on the line, and I wouldn't have to have a filter, because I would be generating perfect, pure power. My wife wasn't real big on the idea of putting a diesel generator in the back, because she just wasn't real big on that. And I thought, okay, well, sorry, but these wives stand in the way of audiophiles all day. I know.
Even in the U.S.
Even in the U.S. It's like, what do you mean I can't tear the living room apart? You know. I remember the day I had some, what were they, acoustats. Remember the acoustat, electrostatic loudspeakers? And one weekend, Terry went away to her mom's. And I was sitting listening to our 2+2. You'll like this. She almost killed me. And electrostats have, and all panel speakers have a problem, is that they're not very sturdy. Like this speaker here, I mean, this thing is, I don't know, 200 pounds. It's a rock. And so when these drivers move, this thing doesn't shake and move much. It's a pretty solid foundation. But a panel speaker is just a couple of sticks. And when it tries to produce bass, it moves back and forth, and a lot of the energy is lost. And acoustats don't have bass to start out with. And so I figured, you know what? I'm going to fix this thing. And so I cut holes in the back of our wall in the living room, and I put 2x4s into the studs and strengthened them. Man, those things sounded great. And Terry walked in, he goes, "What have you done in my living room?" I said, "It's just temporary. I'm just playing." I took it all down, had to plaster the walls and paint them, and she was not very happy. Anyway, she's, after all these years, she's a very understanding wife. She's had to tolerate a lot with me.
Matter of time?
Sorry?
Matter of time?
Oh, yeah, yeah. Actually, I've been thrown out into a separate room, so you go there. So what I decided was I'm going to make an electronic version of a generator, because that way no one can complain. I don't have some big generator out in the backyard, and so that's how the power plant came into being. Until that point, power conditioners really didn't do a very good job of anything. As I said, they robbed the music, and this was the first one that actually brought life to the music and fixed the problems of power, which, as you might know, the problems of power really don't have a lot to do with the cleanliness of the power. I mean, it helps to get that, but the real problems of power are the wires themselves. So I don't care how good the service you have, everything comes from a transformer up on a pole or in the ground, however you have it in your city. And then there's hundreds of feet of wire that go. And when your power amp starts to draw power, if you look on the voltage is going like this to the music. It's turning up and down dynamically. It's not a good situation. The farther you are away from your transformer, the more you get this. Plus, since all your neighbors are using your power, and everything is timed together, so you have this peak, right at the very peak, we're all drawing current right at the exact same time, 50 times a second, right at the very peak, we're drawing power. So if you look at the peak, it starts going down, and it flat tops, and you lose energy at the top, because we're all drawing from the same power at exactly the same instant. And in fact, later, once we get done, if anybody wants to see, we have an oscilloscope built into the front of the power plant. And I haven't looked at the power here, but we can see the distortion, we can see what the wave looks like. Kind of fun. Just remind me of my rationales, and we'll do that. So I wanted to address the real problems of power, which is the fluctuating voltage, the flat topping, all the stuff that actually goes wrong and makes the big difference. So what I did is I basically just built a big power supply that took the AC in, converted it to DC, so now we don't have any AC at all, and then a big power amp that regenerates new power that comes out at very low impedance and doesn't have those problems, and that's what a power plant is. And we kind of put the world of audio on its ear, if you will, by doing that, because all of a sudden people started buying power plants and going, I can't believe this, because power, I had no idea it made such a difference. I've tried power conditioners, it's a double-edged sword, some good, some bad. This is just amazing. So in '97 we came out with the first power plant, and to this day we've got tens of thousands of them all over the world powering systems. And the only real problem with it, and Angie, who's our director of sales, will tell you that when one of them breaks and we don't fix it fast enough, people go into heart failure. It's like, I can't listen to my system anymore. You fix this thing or I'll come over and shoot you. I mean, they get very, very crazy about that. And that kind of leads me to where we are today with our Perfect Wave products, because these audio products are they're a natural extension of the power plant idea. We knew that the reason CD players all sound different, DACs and streaming devices all sound different, is because they're all relying on real-time audio coming in and doing whatever it does, creating different sounds. If you were to be able to get rid of everything in the audio except the data itself, just the audio, then you wouldn't have any difference. So in other words, if you could, and the difference is all the clocks and everything that can control the data in digital audio. If you could get rid of those clocks, if you could just throw those away and put those into a storage device, and then re-clock everything out as brand new data with a perfect clock that had nothing to do with the equipment that it came on, in the same way that we do power, then you would have a system that would always, regardless of how you send it, sound the same. So it would sound the same if you put it through a CD player, or if you streamed it over the network in your home into this device. It wouldn't matter. So that set us off on the Perfect Wave product, and there you have the two pieces. So let me demonstrate one. How many of you have ever played with the Perfect Wave transport?
No.
One. 1.5? Oh, okay. So the Perfect Wave transport is actually the first product that we came out with, and it's called a memory player. Now, a memory player is really what I call the power plant of digital. And what it does is it takes the CD, and instead of what a normal CD player does, which is just streams off of the CD, in other words, the CD is running about 600 RPM, the laser's reading it, and you're streaming that data out in real time. And it goes faster and slower, and there's jitter, there's not jitter. The experience is always different for every transport and CD player that you listen to. This one is very different. This one actually takes the data from the disk and puts it into a big memory. And you never listen to the disk. You're listening only to the memory. And that's why it's called a memory player. So let me demonstrate that to you, and then I'll explain to you why that means anything. Let's see. There we go. I think there's a disk in here. So this is, it's just a regular CD player. You just take a disk and you put it in. So you might think that in order to do this, we'd have to rip that whole disk, and but no. As soon as you put it in, it reads the disk, and like any CD player, it'll come up, and then we can just start playing it. But I'll show you the difference here. So. When the programmers built this thing, it was not easy to do that. I mean, that was a big project. They had designed the thing so when you did that, it automatically cut the buffer off and stopped. And I said, no. let me be able to hit the eject button and go over and show everybody that the CD. Why? It's so much harder. Because it's one thing to say it's a memory player. It's another thing to actually see that actually happen, and you really get the idea when you figure it out. So, and it just keeps playing. But why? So why is that important? It's important because once you can throw away the clocks and throw away all the things that differentiates players and how they sound, then you're just left with the raw data. Now, it doesn't matter if that data is stored on a hard drive, or it's stored on a little optical disc, or it's sent over the internet. It doesn't matter anymore. Once you can take whatever is happening, strip away everything, put it into a memory, and then play it, it will always sound identical. So from day one, we knew if we could do that and prove to the world that this transport, if you're going to listen to a CD, you listen to that, because that sounds better than any CD player by a country mile, and that's the reason why. It's the way it's pulling it off the disc. It'll play 192, 24-bit. It's not just restricted to 16-bit CDs. Once you can do that, then if you can get that onto a hard drive, I can give you the same performance, now streamed over a network, and you can understand how that kind of works, right? So that's what we wound up doing, and once that came out and we showed the world what we could do, then we came out with what's called the bridge. And the bridge is a card that goes into the back of this DAC and allows you to connect up to your home network. And then you can use the iPad or your phone or whatever you want to have a streaming music experience. Put that back. Oh, I got to change it. So this now has fundamentally changed everything I know about high-end audio. For the first time, without any kind of compromise, I can now play from a library like this and scroll through the library, find anything. I've got 6,500 albums that are stored on this little $130 hard drive, just a USB hard drive, and I just put everything on there. And now I have everything available here, and the difference in sound between that and this is gone. And originally, this whole project started because one of our dealers brought over a Sonos. You guys are familiar with the Sonos? Great product. It's very convenient. We have one at home. My wife loves it because it's easy and it's cool. But we use it for background music. It's not a high-end product. You wouldn't want to put it inside of your listening room, even if you have a good DAC. It's just not. I mean, and they never intended it. In all fairness to them. Do you have a question?
Small question.
Yeah.
The problems.
This is not a prepared speech, so don't.
The problems from bringing it from the CD player to the hard drive is still the same.
It is, but it doesn't matter as long as you go lossless. In other words, you don't use a compressed format like MP3, then it'll sound the same. I've got copies on here that are ripped in WAVE, in FLAC, and in Apple lossless, ALAC, and they all sound identical.
Yeah, but the problems from jitter from the CD player is still the same, because you have to bring it on the hard drive.
No, not true. So let's talk. That's a really good question. So what he asked is the problems of jitter that come off of the disk when you put it onto the hard drive are still the same. In fact, that's not correct, and here's the reason why. Jitter is a timing problem. Okay, jitter is because the clocks that are operating everything are moving relative to the data. And it causes a funny kind of distortion that we call jitter. If you have high rates of distortion, like if you take an Apple TV and you try and stream out of an Apple TV or a Sonos, they've got 400 to 500 picoseconds of jitter. When you take something out of a computer and you put it to a hard drive, there's no clock associated with it. You don't keep the clock. So the data is just in raw form, it's just sitting there. And when you spit it back out, depending on how you do it, that's where you can get in trouble or not get in trouble. So you're partially correct, but once it's sitting on the hard drive, there's no clock associated, no jitter.
Okay, but the sound is everything you hear is analog.
Mm-hmm. Yeah.
So you have to make it digital.
Yeah.
But then you have to use a clock.
Yes, correct. And so depending on how you do that, so for example, if you know what an asynchronous clock is? Are you familiar with the term asynchronous? Is it everybody, or should I explain it a little?
Please explain.
Okay, so a synchronous clock is one that, if it comes off of a CD, not that one, but if it comes out of a normal CD player, you have what's called a synchronous clock. In other words, the clock signal is embedded with the data, and it goes together. And that will have jitter and can vary, okay? An asynchronous clock says that there is no clock associated with the data. It's unrelated to the data. And it sits on the output and it clocks the data out. And if you do that properly with a zero jitter or low jitter asynchronous clock right at the DAC, then you don't have to worry about it. And it doesn't matter. But not many people do that. We do that, and we do that in here. So, you know, the fact that this is played out of memory, while it's a good showman trick that I can, that impress everybody, the real benefit to it is that we can do an asynchronous clock. If you can't do an asynchronous clock with a CD player because the data is coming in faster and slower, and you have no clue. In other words, the asynchronous clock is a fixed 1, 2, 3. If the data comes in too fast, it bunches up and it gets lost. So you can't do that. But if you do it the way we do, you can. And we do the exact same thing inside of here. There's a what we call the digital lens, which is this asynchronous device with a buffer. Simple in concept, kind of hard to pull off, but that's so everything we make that has streaming or CD has that feature onto it. None of the data is connected. And actually, you don't mind my just rambling. You've heard of SPDIF? You know how that works? And SPDIF is the Sony Philips digital interface. And it's been the bane of our existence as high-end people forever. So inside of every CD player, if you take a CD player, you have a transport and a DAC. And if you have a transport, you just take the DAC out, right? So then you just have a spinning thing. So this is just a transport. Now normally, using the Sony Philips digital interface, which is that single RCA jack or XLR, and then there's a standard that's called AES EBU, which is SPDIF. There's no difference. It's just the Audio Engineering Society and the British Broadcasting Company said, well, the signals have to be this high, and SPDIF said, we don't care how high. But it's the same exact signal. And what Sony and Philips did is they said, we don't care about high-end audio. I mean, these guys could care less about it. So inside of their CD players, they have a protocol that delivers the audio in a format to the DAC, right? And that is a parallel format, and it's called I²S. You guys have heard of that, right? I²S has a bit clock, a master clock, a word clock, and the data. So you've got 4 separate lines, but most of them have what we call a digital out. And you've seen that on the back. That's the SPDIF. And what happens is the Sony Philips digital interface takes those 4 lines and they multiplex it together exactly down into one thing and spit it out because it was convenient.
It's like composite video?
Sorry?
It's like composite
video. It's like
video.
composite video. It's a very good example, which looks like crap compared to anything else. Yeah. And so what happens is it narrows it down to this one thing. It goes out, and now what do you have to do? You've got to take it apart and put it back into that I²S format. When you do that, you create a ton of jitter. Because just by the very nature of how you have to do it with phase lock loops and all this stuff, it's not a very good way of doing business. But there is a good case, you know, in answer to your question, of one of the big problems. So this, one of the things we did is this transport and this DAC have I2 as inputs and outputs that allow you to take that data without all the, it also has SPDIF if you want, but if you have our DAC, you use that. And we use an HDMI cable to play it, which is kind of cool. But when you're going networking, when you use network audio, that's not a problem because the clock is never associated with it. Same as in USB. As long as you have asynchronous USB, you don't have to worry about the clocking signals. So our big goal was to come up with a system that audiophiles could have the fun of a Sonos without having to compromise the quality of their sound. In fact, they could enhance it. And so we build what I like to call the power plant of audio. Everything is taken down to its core data. All the clocks are thrown out, and our clock only happens at the very end. So everything that happens in our DAC and our transport has that feature, which we call the digital lens in there.
So what I'm seeing there is only a power amplifier and just the transport and the network bridge, and no preamplifier?
There's no preamplifier. So whenever we, and you can hook a preamplifier, but you know, we've always said there's no preamp like no preamp. We argue this all the time, and I think even the store is probably against me on this. I'm just saying it like I see it, boss. You can't put something in line with something else and make it better unless you rebuild the signal like we do. We can actually do that on the power because we're actually rebuilding it. But if you take a preamp, it's actually running through it. It doesn't make it better. It can make it sound better. So I would guess 25%, 15% of our customers of these DACs put preamps between them because they like the sound better. No question about it. And they'll have their favorite preamp. And we tell people. So let me show you this.
One question?
Yeah.
How do you actually adjust the volume? Do you just compress the bit, or do you do it differently?
We do a little of both.
Ah, all right.
Tricky guys that we are.
Yeah,
So,
because if you would only compress the bits, you would lose the dynamic range.
Yeah, right. So most digital volume controls do it with arithmetic. And if you didn't do some tricky stuff, then every time you lowered the volume by 6 dB, you'd lose a bit. And if we only start with 16 bits, as we go down, you're not going to get that much, right? So our DAC is actually a 1-bit DSD DAC. DSD is the same thing as SACD uses. So we upsample the heck out of it and turn it into a 1-bit signal in the DAC itself. That's not through a sample rate converter, which we'll talk about in a minute. Because I don't want to get too, my wife tells me also I talk too much. But anyway, well, I'll try and keep it down. We'll play some music too. So when that happens, the net result of all that, to answer your question, from 50 on the volume control to 100, you get a free ride. Because of the upsampling, we're upsampling to, I think it's like 32-bit. So between 16 and 32, you get a free ride. That whole, from 50 to 100, there's no degradation whatsoever. No loss of bits. From 50 down to 0, you're starting to lose bits. So as you go down every 6 dB, you lose a bit. But here's the interesting thing about it, and a lot of it depends on the efficiency of your speakers and the sensitivity of your amp. So if you're in the sweet zone, to where most of what you're playing is 40 to 60, you're in good shape. You're in the loud things maybe at 65, 70. You won't hear anything. And the reason is because as you start getting lower in volume, if you've got your system set up right, the sound gets below the point that you can hear the lowest music. So when we lose bits, we lose the bottom parts of the bits, which you call the least significant bits. And that's the part where the very lowest level signals. And as the sound gets lower and lower, you can hear less and less of those lower signals anyway. So if they're missing You know, because remember that what the bits give us is dynamic range. You get 130 dB of dynamic range. If you take the whole thing down, you literally can't hear those lower bits. So the fact that they're missing is irrelevant. By the time you're down to 20 or 30, it's background music anyway. But absolutely, any digital volume control to a point, you're going to start losing something. So we give you a free ride from 50 to 100, and below that, you gotta pay. So if that answers your question, you have to design your library the way you think. And later on, we'll talk a little bit about a big project we have going to make this easy. Part of our software that we're designing and building here, we want to make this so that 80 or 90% of this just works for you. And we'll talk about some of the rule sets we can do that we're doing. They're kind of interesting.
Well, we have the problem. We tried the composer as well, but in the lyric, there is no such thing as a composer album drop down.
Right.
And then it doesn't work, because then I'll have all those loose tracks.
Yep, and you need it as a compilation.
Yeah.
Well, in the latest version of eLyric, and I can show you, we added that back in.
Oh, okay.
Yeah, and we're working on more, because as I start doing all the tagging, I see all this stuff missing, and I'm like, oh crap, you know. So I'll show you how ours works. So you've heard my. So there's this coming up. That's all the. I don't know if you guys can see that. So when you select something, like here we have Cantati Domino, and you have the playing now screen. And normally, I'm not connected to the internet, but if you're connected to the internet, then all the information is over here, so you can read the back of the album cover, which is kind of cool.
Where do you get the info?
Last FM.
Ah, all right.
They have an API that we use.
Amazon is good as well.
Yeah, it's pretty good. Yeah. Sometimes it's a little goofy.
Yeah.
But you get some interesting results. But I give it about a 90%. About 90% of the time, it gets it right. Yeah. And it's
even lyrics.
Yeah,
that's fun, by the way.
Yeah, it is. Yeah. One of the things we want to do is they also provide in there all the associated artists that are with it, and I want to put hyperlinks in there so that when you're reading about it, you click on it, and that'll go over to check your library and see if you have one of those guys in there. Nice. So as you're reading about it, you go, oh yeah, bang, boom, you know, and start lining them up.
Kind of like the Genius thing with Apple.
Yeah,
they say, if you like this, then you probably like this.
That. Yeah. Exactly. And if you like this artist. So let me play, so you can see over here I've got, you probably can't see it actually. I can't even see without my glasses. Here's my high resolution section. And let me play.
What is high resolution?
How
high?
192.24. Okay. So this is, I'll play you a 192.24, is that okay? We'll just do a little, because I'm tired of listening to me talk. No? Let's see, okay, this is a good one. Let's do that one, okay. So it's a real intuitive screen. So I just touch that, it says play now, I click it, and it starts to play. And then if I want to do the playing now screen, then there it is. So this is 192.24. Are there any Questions?
Yeah. What about the gapless issue? Is it solved already?
Well, yes and no.
What's the gapless issue?
That you
Thanks a
hear
lot.
the album as it is intended to be.
Yeah.
The Pink Floyd.
When
just one.
Yeah. So, like Dark Side of the Moon by Pink Floyd, it should be played gapless. In other words, no gaps.
Okay. Yeah.
And when we first brought the bridge out and the e-lyric software, it didn't do that. So then we've worked for quite a while to make it. So now it'll do it. The issue that is now that people are not happy about is that within you can't like scroll forward like you want to. It'll skip if you do that. So that the actual control of it, once you do that, is not finished.
Okay.
We had to pull our chief programmer off of that onto another crisis. And he's on vacation for the rest of this week. So as soon as he comes back, he's promised that that'll be finished. But it does play gapless, so now you can listen to it. Yeah.
These things are updates or whatever.
Oh yeah, it's all software updates. Yeah.
Okay.
Yeah. So
when I play WAF, I get like a scratch at the end of every song.
you know that's
What is that?
I don't know because we don't get that.
I use one and the same program, and at the
What
same time,
program do you use?
I use XLD. It's for Apple.
I don't know.
XLD. Okay. Yeah.
It's a ripper, so it's the
No,
same.
no, no. What do you use for a server? Do you use our program?
No, I use Twonky Media.
Twonky. Okay.
So I've got so when I rip it at the same time in WAF and in FLAC, and with WAF I get a at the end, like you get off the, and when I play FLAC I don't get it.
Yep, on the forums, you're not the only person that has said that, and so far, here, let me just pass it around. If you guys want to, I have it on low volume, if you want to just select something, go for it. We can just talk about it. I don't know the answer to that. I suspect it has something to do with the way that Twonky is handling it. Part of the issues that we've had is that all of these server programs tend to do something a little different, including ours. This is a fairly new form of stuff. Oh, that's an old one. Wow.
High resolution.
Yeah. Oh yeah. So for those of you that aren't totally familiar, there are 4 elements to any streaming music system on the planet. I don't care whose it is. You've got a server, a player, and a controller, and the storage somewhere. So that can all be on one machine, or it can be on multiple machines. And the way the system works is the server, which is a software program, is tied somehow to the storage. So the server knows, like, let's just keep it real simple. Let's say I have a hard drive with one album on it. The server knows that there's a certain memory location. It's a hard drive basically is just a big memory thing with specific locations. So it knows that track 1 is here and track 2 is there, right? Just to keep it real simple. And then the controller is a device that's the human interface. That's can be a computer program again, or your iPhone, or whatever. And so the way the system works, and then a player is a DAC or whatever you have that's actually playing it, right? So what the controller does is it's a fairly smart device. It goes out and it says, tell me if there are any players, and then it goes on the network and finds the players and lists them, and tell me if there are any servers, and it lists the servers. So if you say, I want that server and that player, then you're connected up. So then you want to see what's in your library on the controller. So the way that works is the controller says to the server, hey, what do you got in there? Display everything you got, and it sends the data, and you see it like on the iPad. When I say play this, I send a command to the server, and the server says, oh, okay, and it grabs the song and opens a path up to the player, and it starts to stream. So that's the system. On the way this all works, it's supposed to be compatible. and it's called UPnP, which is Universal Plug and Pray. Well, you know, I mean, this is the problem that now I'll tell you right up front, disclaimer, I hate Windows. I don't like Windows. I know most of you guys are Windows, so you probably hate me because I'm the Antichrist. I'm a Mac guy. And I'm a Mac guy. Somebody, okay. I like Macs because they just work and they're a pleasure to use, and that's what machines should be, in my opinion.
Come on.
Yeah, I'm just saying.
Windows works as well.
Yeah. Well, Windows work, and I started with Windows.
Windows 7
I've had it forever, yeah. But the problem Windows has that Macs don't is not really the fault of Windows. It's the fault
of the users?
fact that it's that it's an open hardware platform.
Yeah, it is.
Right? So you've got a bazillion guys making something to a standard that takes an operating system, and there's 50,000 different pieces of hardware running around, all Windows compatible, and they're all different. So the poor guys at Windows, I really feel sorry for them, because every time it doesn't work, or you have a new driver or a printer, you know, they have to make everything work with everything, and that is a huge challenge. Apple, you know, this is one thing people hate about Apple, but they also love it, is that they make the hardware, the software, and it just works. That's why it just works. So, because of that, what we've decided to do, turn it down a little bit. We've created a product called the Silent Server, and if you've been on the forums, you probably know about the Silent Server. So, the Silent Server is a product to be out this summer, and it basically is a dedicated computer in a little box. And the reason we're building this, there's a bunch of them, but it's the Windows Mac thing. eLyric, Twonky, JRiver, all of them struggle to work perfectly well without too much prayer on multiple pieces of hardware. And this is the thing that we struggle with, that you've got an instance where you've got a scratchy sound between waves, and if you changed your server, you may not have that, or you know, I don't know. I mean, if I knew the problem, and we're working as hard as we can to get those issues done. What we've finally figured out is that for a company our size, we're one of the larger small companies. I mean, we're not Windows, we're not Apple, you know. So as a that's all right. As a smaller company, we have to make some decisions, and one of those decisions is we want a user experience that is hassle-free. That I never have to hear you say, you know, because you're sitting and listening to this wonderful music, and then it goes, yeah, that sucks, or ticks, or you know, that's no fun. I mean, it takes all the fun out of it when something doesn't work. So by building the Silent Server, what we do is we control the hardware, we control the software, and we can make a user experience that is just unblemished. And you don't have to have a computer involved. You hook this thing up, it's completely automated, it just works. You set it in your thing and you forget it. The second instance is somebody who wants to take that to a broader experience like we're doing here, and networking it. You do exactly the same thing, except you just plug it into your home's router. And your router is in the washing room. It doesn't matter where it is. And then that just works. So you can, once you buy it, then if you want to, you can elevate up to that, and then have multiple units throughout the house.
And then can you use your existing NAS server?
Yes. Now in that instance, it's not completely automatic. No. So in that instance, you have to go on the computer and connect with it and say, point here, and then you're done.
So you can use my iPod Touch.
You can use your iPod Touch even if you don't, I mean, under any condition. Because it'll automatically just find it and hook up.
So I can buy the software on.
You don't, when this comes out, we'll have new software and it'll be free.
Oh,
so pretty much every existing, I'm on my third NAS now.
I don't support NASs, by the way, but as a company we will. And I'll tell you why I don't support NASs. I don't recommend any of you get a NAS. And the reason is, I know, sorry. Well, you know.
Well, tell me what I did wrong.
No, you didn't do anything wrong. The problem with a NAS is that so, you know, let's just say real quick, what is a NAS? A NAS is a hard drive with a small dedicated computer inside and a network interface. Okay? That computer is more than likely going to have some type of server on it, which is usually twonky. And twonky is just, you know, now you don't have to use twonky. You can, in like the case, you can point our software to the NAS and say, use that as your storage. Because it is, at the end of the day, just a network attached storage, which is what NAS stands
You
for.
just have an additional server or a server outside of the
But there's
Geen
most of them, they're little dedicated computers that are slow.
But for instance, if you have an iTunes server inside,
Yeah.
this should be sufficient.
No, because iTunes does not stream.
Oh, yeah.
So you can't do that. But you know, so we got a lot of people that use NASs and love them and don't have a problem with them. And they just point to it and forget it. And that's, you know, the only time you're going to probably run into trouble with that is once we finish our whole system. This will be an expensive piece. You know, it's like $4,000 or $5,000, whatever it is. We'll have lower cost ones that you can start putting throughout the house that are well under $1,000 that hook up to a pair of bookshelves or your desk, and then all of a sudden now you have 4, 5, 6, 7 of these throughout the house, and now your NAS is going.
First is your analog stage after the DAC. It's no use of op-amps.
No.
And it's not Class A.
It is Class A.
Ah.
And we don't like op-amps. We don't use op-amps.
Okay. I'm green.
Yeah.
I'm green. And second, your choice for the Wolfson DAC.
Why did we make that choice?
Yeah. For example, the Sabre.
I'm not a big Sabre fan. I know a lot of people like the Sabre DAC, and I've heard some good implementations. Let me tell you a little secret about DACs. In general, DACs pretty much sound alike in many, many respects. Sorry?
I like the sound low. I can
okay.
hear you. He has this, okay.
It's really difficult to slide, so
He's
just
focused on that.
Oh ja, maar ik ga niks doen.
That was the battle. I think the volume was winning. Yeah, okay.
You're winning.
Sort of. The way a DAC sounds is almost completely dominated by the analog stage. That really, as long as you have, you know, reasonably close DACs, yeah. It's the filtering in them, how they do that, which is what I love about the Wolfson, because they have really, really good appetizing filters that we can select on the front here. And the way you implement the DAC, and most of the analog stage. One of the issues with the DAC, and we should talk about this real quick, is the vast majority of DACs out today use sample rate converting, and sample rate converters to do it. Probably on the order of 99% of every modern DAC uses sample rate converters. And they'll tell you, and we do the same, so I'm not singling out that, but those sample rate converters are not a good idea, and they don't sound good. So on our DACs, we give you the sample rate converter, which went against my better judgment, but you know, you got to have people like Angie this is Angie who runs our sales department, and she's great. She keeps me honest. So we kind of had to because people expect it on there. But we have a feature on here called native mode. And native mode bypasses the sample rate converter. And yeah, and you can turn it on or off.
That's good.
Yeah, if you'd like to, I can do a demo for you. And I'll tell you the demo that I'll do. And let me explain just something real quick about do we have time?
We take the time.
Okay, all right.
10, 15 minutes, yeah.
Okay, yeah. They have to have a hook.
It becomes interesting.
So sample rate converters, let's talk just real briefly. Most companies will tell you in their DACs that at the DAC they have zero jitter, very, very low jitter. And they make a big marketing claim, as do we, that there's very low jitter right there. The fact is that the sample rate converters do get rid of jitter, but they do so in a way that uses a secondary clock to manipulate the data, to move it in time back and forth to get that jitter low. And the net result of that is sonic degradation. When I do a demo for you, we'll find something to play on here. And I'll go from, we'll just take a 44.1 Red Book CD, and I'll play it. And then there's one we did here, I think you heard it pretty well, kind of a masked choir. And when I go then to the sample rate converter, and we'll keep it right at the same sample rate, at 44.1, so with native and without, you'll hear the chorus kind of go, just kind of get crowded in. And that's the sort of effect that these things have. Now, in most DACs, you can't bypass the sample rate converter, so you can't hear this difference. You just take it on its own. But all those things go together and conspire to create the sound of the DAC. So when we chose the Wolfson for a whole bunch of reasons, but we've tried the Sabre, and it's a lot more money. And I don't think it's worth the money. I would rather put the money into what we did. So if you look in there, you asked the question if we use op amps. And I'll give you 3 answers just because you're from Belgium. We don't use op amps, and we also don't use surface mount parts in the output stage. We use plenty in the digital stage because you kind of need to. But in the output stage, we use, and this is after some hard experience, we use all old-fashioned $2 PRP resistors, real capacitors is what I call them, things that I can actually see. I can't work on any of our products anymore. If you come to PS Audio and look around, there's microscopes everywhere, and there are people looking through microscopes doing, I mean, it's crazy. You know, I'm Lord. But surface mount parts in general don't sound as good as what I call real parts. Real resistors, real capacitors. So we go to a lot of trouble to do that. This Mark II board in here, so you guys, by the way, we're 4 hours into the first demonstration of the Mark II in anywhere in Europe.
Cool.
That's one of the first ones here.
I have a question about that. What's the difference between the Mark II and the PS Audio that I bought a half a year ago?
The Mark I?
I don't know.
Oh.
Yeah. It never says whether it's Mark I or not.
Well, do you have a perfect wave DAC?
Yes.
Oh, then you have a Mark I.
Yeah.
Yeah, clearly, because that's the only other one in Holland.
So what's the difference?
The difference is in the digital processing board. We completely redesigned it. And you can upgrade. It's a fairly simple because and that's one of the things that we you know, progress is inevitable. We're going to make changes, but we want to make sure that somebody that bought, like yourself, that bought one can upgrade and have a Mark II if you want. So we've gone from 3 power supplies to 14 on there. We've gone from using digital gates to do all the digital switching. We now use all analog gates. I think we're maybe the first people to do that. It's kind of, there's a long story behind that too, but it's a lot more analog sounding, if you will. And we put a digital lens that you can turn on or off from the front panel for any of the inputs, whether it's CD or the transport or whatever. So it's definitely a worthwhile upgrade.
Would you rather turn it on or off?
I listen to it always on.
On.
Well, no.
Why do you give a choice, actually?
You know, that's actually a really good question. We give the choice, A, because our core audience, audiophiles, like to mess around with stuff and play with it. I mean, that's the honest answer. And if, you know, when did I do the demo for the transport with the memory?
Yeah.
Okay. Well, the funny part about that is when the programmers built that, we spent almost 2 years with that. My expectation was when I took it out, that would happen. they spent about 2 weeks writing code in there that make sure that wouldn't happen, because they thought that was stupid. I mean, when you hit eject, you want the music to stop, right? You don't want it to keep playing. It's dumb. And I said, no, I need to go out and demonstrate this to people, and our customers want to show it to their friends. Yeah. And so, you know, why do we give you a choice of 5 filters on the front when 99% of our customers will play with that for about a week and then put it on auto and never touch it again. 3 hours. Because that's part of what we do. Why do we put balance controls on preamps when 99.9% of the people use it as an appendage? It's nothing. You never touch it. In fact, most people I know.
Check if something is.
Yeah, well, if the balance control is turned just a little bit, people get uneasy and they're like, you know, something's wrong. And this is interesting on the Mark II. Just to answer your question, we added a balance control because now we can do it for free. And now we can do it without any degradation at all. Formerly, if you put an analog on, you're going to degrade the sound just a little bit, and no one ever uses it. That's why we took it off. It just offended me because no one uses the thing. It sounds worse because I have it, and that's dumb. Now we can put it on. There's no cost. There's no loss, and there is a need for them. These speakers are not matched. I guarantee you, these things are at least a dB off, and probably 2 or 3.
Yes. What about, maybe it's a nasty question, but
that's all right.
What about the future? You now sometimes see formats like DXD, 352 kilohertz, for instance. This isn't able to do that, right?
No, this can go 192, 32-bit.
Yes.
Is its limit. What happens when they double that sample rate? We will follow the source material. So, I mean, let's face it, there's not a lot of 192, 24-bit stuff out there, but it's growing. You know, HD track, they do mostly 96.
HD tracks you see more way.
Yeah, it's coming.
172.
Yeah.
Strange enough.
Yeah, well, and that's you know, that's great, and it's growing. I bet there isn't anything out there in source material that's worth listening to, or at all, that's at this higher bit rate. So once that starts to come and there's enough source material, then we'll upgrade it.
And your radio station is gonna bring that too? The internet
no,
station?
the internet station right now, all that's really practical is about what we're doing. Any more than that over the internet, and it starts to become just a real hog.
But you can 69,000.
Well, we do 192
on the internet.
We do 192.
192. Oh yeah.
Yeah. We do 192 kilobits. Yeah. Oh, it sounds good.
And then,
it sounds good. You could do more. One of the other features that eLyric's going to have, by the way, that I think I'm kind of excited about, and it'll only be in the silent server, is that it'll have a web service available in it, so that anywhere you are in the world, you can log on to your eLyric silent server, manage your library, and play your library remotely. And depending on what our attorney winds up letting us